This is section 7.1 notes. We're going to start talking about exponents in chapter 7. So today we're going to start with the exponent 0. So when you have a number or a letter with 0 as the exponent, it always equals 1. So 4 to the 0 power equals 1. It works the same way if you have your number or your letter in parentheses. So in parentheses I have -3, and then on the outside I have it to the 0 power. This is still going to be 1. It does not matter if the number is a fraction, a decimal, or even a letter. As long as it's inside the parentheses with the 0 on the outside, it's going to be 1. Now taking a look at this last one, the negative sign is actually on the outside of the parentheses. That is not affecting the 3.5 to the 0 power at all. So this is still 1. And because the negative is on the outside of the parentheses, it stays on the outside part of the number. So negative and then parentheses 3.5 to the 0 power should equal -1. Because it's on the outside, it stays. Okay, so next we have negative exponents. So in order to use negative exponents, we need to move them in order for them to become positive. We must have positive exponents. So we need to have a way to get rid of the negative exponents. So in this case, I have 7 to the -3rd power. This is the same thing as 7 to the -3rd power over 1. I just made it a fraction. Now, when I say move the negative, that means I'm going to move the exponent as well as whatever it's attached to. So this is attached to the 7. So I'm going to move that to the bottom of the fraction. So now I have 7 to the 3rd power. That movement took my -3 and made it positive. But now I need a placeholder for this top part here. So that's just going to be 1. So 1 over 7 to the 3rd power. Now I can actually plug into my calculator 7 to the 3rd power and get that to be 343. So my final answer is going to be 1 over 343. This works the same way when you have parentheses. So this whole thing can be written as a fraction just by putting it over 1. So I can put everything in the parentheses, move that down to the bottom of the fraction. So still going to be in parentheses, -5x. The only thing that changes when I move is the exponent. Instead of being to the negative second, it's going to be just to a +2. Again, I need a placeholder, so that's going to be 1. Because this has a variable, the x, I cannot simplify it any further, so that's going to be my final answer. 1 over parentheses -5x to the +2nd power. The only thing I did here was I moved where the location of the parentheses and the exponent were in order to make that exponent positive, because I must have positive exponents. This next one is a little bit tricky. It's 7x to the -5th. Now sometimes it helps me to actually write out the operation that's going on here. Because they are not in parentheses, they're not a group. 7 is separate. So it helps me if I put a little multiplication sign there to separate them. So this is really 7 times x to the -5th. Now I can still write this as a fraction over 1, but when I'm looking at the exponent, this -5 is attached to the x and the x alone. Like I said, 7 is separate. So 7 stays on the top. So we're going to have 7 over, now I'm going to move the x to the -5 to the bottom, so now it's x to the +5. Again, because I have a variable, I can't do any more simplification, so I leave it just like that. 7 over x to the 5th. Now, this next one, I have a whole fraction, and it's in parentheses, and it's all to the negative exponent. Now, something cool happens when you have a fraction with a negative exponent. All that the negative exponent does is it flips or it moves the whole fraction. So what was on the top of the fraction goes to the bottom. So 4c is now on the bottom, and what was on the bottom of the fraction now goes to the top. AB goes to the top. It's still in the parentheses, so it flips the fraction, and then the exponent becomes a positive. So now it's AB divided by 4c, all in parentheses, to the positive fourth power. Again, because we have variables, this is as simplified as I can get it. The next section is a guided practice section. Go ahead and complete this section, and when you're done, pause the video, complete the section, and then play the video again to see the correct answers. This first one should equal 1 over 81. This next one, because everything's to the 0 power, is just going to be a positive 1. Next, we're going to move on to simplifying exponential expressions. So this is what happens when we have multiple parts. So for this first part, I have 5 a to the third b to the negative second. So this is really 5 times a to the third times b to the negative second. So 5 is separate from a to the third is separate from b to the negative second. So 5 is fine, a to the third is fine, that's already positive, but b to the negative second has a negative exponent, which means I need to move it. So I'm going to make this a fraction, put it over 1, and just the b part needs to move because that's the only part that has the negative exponent. So I can keep 5 and a to the third at the top, but I have to move the b down below in order to get that to be a positive 2 instead of a negative 2. So that is my final answer. I moved that negative exponent b down. So similar with letter b, I'm going to move this x to the negative 5 up on the fraction. So I'll have 1 times x to the positive fifth, all over 1. Now notice how I have 1 and 1, they actually cancel each other out. So this will just leave me with x to the positive fifth as my simplified part. This next part, I have to move the a up because it has the negative exponent. So it'll be 2 times a to the positive third, because I moved it up, over, now because I moved this up, I have a placeholder of 1. Now I need to simplify. Anything over 1 is just itself. So this is just 2a to the third. And that's your final simplified answer. So this next part, we're going to be plugging in. And we have a expression that's a little bit complicated. So it says, what is the value of 3 s to the third t to the negative second for s equaling 2 and t equaling negative 3? So I'm going to eventually plug in 2 wherever I see s and negative 3 where I see t. But the first step is to simplify this. What I mean by simplify is I have a negative exponent and I'm not supposed to have a negative exponent. So what I need to do is rewrite this so that this negative exponent moves to the bottom. So that'll be 3s to the third over t to the positive 2. I just moved that to the bottom to make it a positive 2. Next, I just need to plug in the numbers. S becomes a 2 and t becomes a negative 3. So at the top I have 3 times, instead of s it's 2 to the third, over, on the bottom I have negative 3 to the second. Now, because I have a negative number here, it's actually going to be helpful if I put it in parentheses. If I put it in parentheses, my calculator will be able to do it. If you do not put a negative number in parentheses, your calculator messes up the order of operations. So, if I simplify this, 3 times, well, 2 to the third is 8. And then on the bottom, negative 3 to the second, negative 3 times negative 3 is 9. And then one more step, 3 times 8 is 24. So this is 24 ninths. Now, this is a fraction. However, I can simplify. Is there a number that goes into 24 and 9? Sure, 3 does. So I'm going to divide each part by 3. So that simplifies down to 8 thirds. So the simplified fraction should be 8 thirds. Next, I did add 3 more complicated problems. So if you need to, please pause the video and add these into your notes. These would be good problems to put on your frame. So for number 1, we have 11a b to the second c to the 0 divided by c to the negative fifth. So I'm going to circle the parts that have the negative exponents on them. and I'm going to move them. So b to the second is going to move to the bottom, and c to the negative fifth is going to move to the top. Everything else stays where it's at. So 11a and c to the 0 stay on top, and then c to the negative 5, this becomes positive. C to the positive 5 now goes to the top. On the bottom, the only thing that I'm going to have down there is b to the second power because I moved it to the bottom to make it a positive 2. Now I can simplify this even further because c to the 0 is really 1. So if this is 1, I have 11a times 1 c to the fifth over b to the second. Now to simplify this, all I have to do is multiply the numbers. What is 11 times 1? 11 times 1 is 11. And the letters stay the same. A, c to the fifth, all over b to the second. Quite a few steps there. Like I said, a little bit more complicated, but take it one step at a time and it should be okay. Okay, this is number 2. 3x to the negative 2 over 7 parentheses yz to the negative third, w to the ninth. Again, I'm going to circle everything that has a negative exponent on it. So x has a negative 2, and this whole parenthesis has the negative 3 attached to it. And I'm going to move them. So if it's on the top, I'm going to move it to the bottom. If it's on the bottom, I'm going to move it to the top. Everything else gets to stay where it is. So the 3 gets to stay on the top. The 7 and the w to the ninth get to stay on the bottom. And now I do my moving. X to the negative 2 has to move to the bottom, so it'll become x to the positive 2. This whole parentheses with y and z in it moves to the top, and it becomes positive 3. There's nothing else I can do to this, so this is my final simplified fraction. And number 3, I have 2 divided by z to the negative third. The only thing that has the negative exponent on it is the negative third with the z, so I'm going to move that to the top. The 2 gets to stay. So it becomes 2z. Now it's a positive 3 when I move it. All over, if I move this to the top, there's nothing else on the bottom, so I need a placeholder, which will be 1. Now I can simplify. 2 divided by 1 is just going to give me 2, and then z to the third. So my final answer should be 2z to the third.